Suppose the cost in dollars of manufacturing n 100 widgets. What's a widget? It's a whatchamacallit. Suppose that cost is given by C of n equals 3n squared minus 2n plus 11. Find the number of widgets that minimizes costs, the cost actually, and calculate the minimum cost. Does everybody see that the procedure here is going to be the same? We're going to find the vertex. Now, if you think about the last problem, if you were to graph the parabola in the last problem, the value of a was -2, so the value of a was negative. So what would the parabola look like if you graphed the parabola that goes with this quadratic function? Would it open up or down? It opens down because a is negative, right? And that makes sense then that it has a vertex whose y-coordinate hits a maximum, right? But in this one, in this problem, the a is 3, which is positive, right? So what kind of graph do you expect? It's a parabola, but it doesn't open down, it opens up. It's a happy little parabola, which is associated with a minimum height, right? So it makes sense we're going to try to minimize this function, not maximize it. Okay, so same procedure. We're going to find h, the first coordinate of the vertex. So negative b over 2a. Plug that in for me. What do you get? What's the opposite of b in this example? Well, what is b? -2. So what's the opposite of -2? 2. So 2 over 2 times 3. What's that turn out to be? 6. Yeah, so 2 over 6, which is 1 over 3. Okay, so what is that? Well, okay, wait. Let's just look at what the input is. What's the input for this function c of n? The input is always whatever's right here when you have it in function notation, right? The input is n, where n is in hundreds, right? It's n hundred widgets. So it's 1/3. I mean, just literally, what is it? 1/3 100 widgets. That's not how we would say it, right? 1/3 100 widgets, but literally that's the translation. Well, I suppose we need to round off, right? So about how many widgets? Well, what's 1/3 of 100? 33, right? 33 1/3? Yeah, but I mean, how do you create 1/3 of a widget if it's a physical object? I don't know. So about 33 widgets, if we round to the nearest widget. I just like that word, widget. Okay, about 33 widgets. Now, when we compute k, let's not round off. Let's round off at the end, not when we're making the calculation. So we're going to compute k. 33 widgets, I guess is what it should have said. So that's the number of widgets it would take to what? That you would produce in order to do what? Minimize costs. The idea is if you produce more, maybe manufacturing or labor costs, maybe overtime or what have you, your costs are such that you don't sell enough of these things to make a profit. So maybe they're really high-end items, so you don't make very many of them. Okay, so k then would be what? The second coordinate of the vertex would actually be what? Well, okay, so it's a second coordinate. Would everybody agree k is an output value because it's the second coordinate? And the output here is c of n. So what does c stand for? Well, it's the cost in dollars. So k is going to be the actual minimum cost, right? It's always the second coordinate of the vertex k that represents the minimum or the maximum. So k is going to be the minimum cost. So you're going to plug in 1/3 into the function. to compute that minimum cost. You're going to plug in the h value of the vertex, the first coordinate of the vertex. So you get what? 3 times 1/3 squared, plugging in the 1/3 in for the n here, minus 2 times 1/3 plus 11. You could run that through your calculator, but I think we can do that by hand. It's actually not that hard. Let's try it by hand. 1/3 squared is 1/3 times 1/3, or 1/9 times 3 would be 3/9, wouldn't it? Which would be 1/3. Minus, what's 2 times 1/3? 2/3 plus 11. Plus 11 there, and then 3/9 reduces to 1/3, so we have 1/3 minus 2/3. What's 11 in terms of thirds? If you multiply by 3 over 3, think of it as 11 over 1. Multiply by 3 over 3, 33 thirds. Okay, add them together, what do we get? Well, okay, 1/3 minus 2/3 would be negative 1/3 plus 33 thirds, 32 thirds, which would be what? How many times does 3 go into 32 without going over? I think 10, right? And then 2/3 left over. So K is in dollars, right? So just logically, you might care about 2/3 of a dollar, right? Yeah. So I don't know how much you'd want to round off here. So although, you know, it depends. It depends. It may not make if you're going to round the other number to 33, it might make sense to round in the first place here. It just depends on the application. Depends on what the widget really is. So this is about $10.67 if you round to the nearest cent. And we'll just keep it there because we don't know how we're not told how to round this. We don't know what the widget really is. So I'll just leave it there.